Hi guys, today we're going to learn about how to solve rational equations. So the first thing that you're going to do when you have a situation like this is you're going to get the least common denominator of course, the denominator. Here you know that it's pretty straightforward because you only have m minus 4, so the least common denominator for this equation is going to be m minus 4. After that, you need to realize if you have restrictions. Okay, so for the restrictions, you don't want the denominator to be 0 because you have a non-definition. So you know that your restriction in this is going to be m such that m is going to be different than 4. You don't want 4 here because that would make your denominator 0 and that would be an indetermination. So this is the restriction. Now, let's deal about solving your equation. So you have the equation m is equal to 1 over m minus 4. Okay, so since I want to solve this equation, what I'm going to do is I'm going to multiply both sides times your least common denominator. In this case, your least common denominator is m minus 4. Okay, so I multiply both sides times m minus 4. Okay. As you can see on this side is very convenient because you cancel out this. Okay, so after that you have you can distribute this, so you have that it's going to be m squared minus 4m, and this is going to be equal to only 1. Okay, so from here you know that you can have a quadratic equation in the form m squared minus 4m minus 1 equals 0. And you know that here, since it's not straightforward, the factoring, I will use the quadratic formula. Okay, so using the quadratic formula, you know that m is going to be equal to 4 plus minus the square root of b squared, which is 4. So you know that it's 16 minus 4 times a, which is 1, times c, which is negative 1. Everything inside your square root, everything divided by 2 times a, which is 1. Okay, so having this, you know that this is going to be equal to 4 plus minus, and then you have that this is going to be 16 plus 4, which is 20. Okay, and this is going to be divided by 2, so you know that this is going to be equal to 2 plus minus, and it's going to be the square root of 5, right? So I'm just going to put here my solution, okay, my two solutions, and that's your solution. Okay, so for number 2, similarly, since I know that I'm going to run out of space, okay, I have this new paper here. Okay, so the first thing that you're going to do is you find the least common denominator. Here you realize that you have a quadratic equation, but you are like, hey, I can factor it. Okay, so how can we factor this equation? Well, surprise, surprise. Two numbers that when you multiply them, they give you positive 3, and when you add them or subtract them, negative 4, that's going to be the beautiful number negative 1 and negative 3. Okay, so here you have that the least common denominator. Least common denominator is going to be x minus 1, x minus 3. Why? Because you have this one here, and you know that this one has the combination of both, so that's your least common denominator. Okay, so the next thing that you are going to do is the restrictions. Okay, so if I want to find my restrictions in this situation, you need to make sure that you have all the options where your denominator is not equal to 0 or equal to 0, and then you cancel them. Okay, so you know that it cannot be 1, it cannot be 3, it cannot be 1, and it cannot be 3. So you have that x such that x is different than 1, intersection x different than 3. Okay, so those are the restrictions that you have because I don't want my denominator to be 0. Okay, now moving on to that, you are like, okay, so I have my equation, let's write it here. Let's rewrite and rewrite it here. So you have that it's 2x divided by x minus 1 plus 1 divided by x minus 3. This is equal to 2, and I'm going to just write it with the factor way, so it's easier for you to see what's going on. Okay, so let me just move this here. Okay, so now you are here, so I'm going to multiply both sides times the least common denominator. Okay, so this side is pretty easy to see that you're going to multiply all of that, and that's why I'm putting parentheses, times x minus 1 times x minus 3. Okay, on this side, what happens? You need to multiply the whole thing times x minus 1, x minus 3. Okay, so please remember that on this side, what we need to do is we need to distribute this equation here and here. Okay, so I'm going to do it pretty quickly so you can see all the steps. Okay, so if I distribute this here, okay, so what do you have? When I distribute that one, the x minus 1 and the x minus 1 cancel, so I have that it's going to be 2x and then times x minus 3. Okay, when I distribute all this chunk into this one, what cancels? The x minus 3, so I have technically a plus 1 times x minus 1, and then you have the equal, and then when you multiply this times this, what happens? This cancels, so you only have the 2. Okay, so after that, what I'm going to do is I'm going to distribute this 2x here and here. So what do you have here? You have 2x squared minus 6x. Then you have this, well, you distribute that, but in this case it's just pretty straightforward, this. Okay, and this is going to be equal to 2. At this point you are like, well, it's looking like a quadratic equation, but I need to add the like terms. Yes. Okay, I would move this one to the other side so it's equal to 0, and worst case scenario I can factor or apply the quadratic formula, whatever it's convenient for the case. Okay, so you have this, then I have that negative 1 minus 2 is negative 3, this is equal to 0, and then we can easily factor this as 2x plus 1 x minus 3, and that's equal to 0. Okay, so you are like, oh, okay, so I can solve this as a quadratic equation. Yes. Okay, so you know that if you solve this as a quadratic equation, you have two options: 2x plus 1 equals 0 or x minus 3 equals 0, and then solve each one. You know that this is going to be x equals negative 1/2, and this one is going to be x equals 3. Okay, after that you need to be super careful. Why? Because if one of these is part of the restrictions, which is happening here, this one is good because it's neither 1 nor 3. But what's up with this one? This one, you don't want it, right? This one, not a good solution, so watch out. So what's your only solution for this problem? For this problem, your only solution is going to be negative 1/2. Okay, so that's for number 2. Okay, so for number 3, what we have here, again, here you know that your least common denominator is going to be, well, I'm going to just write it here. Least common denominator is going to be x minus 2, x plus 2. Okay, so here the restrictions that you have, okay, the restrictions that I have is x such that x is not equal to 2, the intersection x different than negative 2. Okay, so you're like, okay, so far pretty similar to the previous one, but it looks like I'm going to run out of space again, so let me get my paper here. Okay, so you have that your equation is x plus 2 divided by x minus 2 is equal to x plus 6 divided by x plus 2. So here I'm going to multiply it times your least common denominator. Okay, the least common denominator, it was x minus 2, x plus 2 on this side, x minus 2, x plus 2 on this side. Okay, so this one is pretty straightforward because I only have what was it, one term in each side. Okay, so this one I just multiply it to this, okay, and this one I just multiply it to the whole chunk, okay, like this. Okay, I would see it like that. Okay, so what happens here is you cancel this x minus 2 here and here. So you have that it's going to be x plus 2 times x plus 2, which you can see the pattern there. And then here you can cancel this with this, having x plus 6 times x minus 2. Okay, so after that, you know that this is basically square, okay, x plus 2 squared, so that's going to be x squared plus 4x plus 4, and this is going to be equal to, I would FOIL it, okay, so it would be x squared, and then you know that it's going to be plus 4x, and that's going to be equal to negative 12 because I multiply those two. Okay, so that's what you have. Okay, then when I solve this as a quadratic equation again, I realize that these two they cancel, these two they cancel, and you are going to tell me what 4 is equal to negative 12. What do you know? Well, you know that this is obviously not true. Okay, so this one is going to be like, I know that this is not true. So what's the solution for this problem? Nothing. Okay, so you have no solution or the empty set. Okay, so that's what you have for number 3. For example number 4, what you're going to do here, you realize that you don't have any variables at the denominator, so either way, the first thing that you do, you find your least common denominator, and your least common denominator in this situation is clearly 6. After that, you ask yourself about the restrictions. Okay, so the restrictions that you have here, no number will make the denominator 0, so the restrictions are none. Okay, so you don't have any restrictions, which is pretty nice. Now, the next thing to solve your equation, what you're going to do is you are going to multiply both sides of your equation times the least common denominator, which in this case is 6. So you multiply both sides times 6. So on this side it's pretty easy to see that this is going to be a beautiful 5. On this side, what you're going to do is you need to make sure that you distribute the 6 here, having 3x. On this one, you know that you need to distribute that 6 here. Okay, so you need to be careful there. The 6 and the 6, they cancel. But then you need to distribute this negative here and here, so you have negative 3x plus 5. And this is going to be equal to the 5 that we have here, so these two they cancel, so you have 5 equals 5. This is a true statement. Okay, since it's a true statement, you know that, well, I haven't solved, but if you arrive to a true statement, you know that there's a solution, and actually the solution is all real numbers. Okay, so in this case your solution is going to be from negative infinity to positive infinity. And why is that? You don't have any restrictions, so that's why we have all real numbers. Okay, so that's your solution. For number 5, what you have here is this expression. Okay, so the first thing that I would do here is to factor this quadratic denominator. Okay, so when you factor this denominator, you know that it's going to be x minus 3, x minus 2. Okay, in the same way that the second thing that I would do here is finding my least common denominator, that in this case you know that it's going to be x minus 3, x minus 2, and you know that because that's a shared denominator, and same with this one. Okay, then the restrictions that you have for this situation are going to be 2 restrictions. You have x such that x should be different than 3. Okay, and you don't want the x to be what? 2. Okay, why? Because if we put the 3 here, that would be undefined. If we put the 3 here, that would be undefined, in the same way that if we put the 2 here and here, that would be undefined. Okay, so you have those restrictions. After that, you are going to multiply your expression times the least common denominator. Okay, so you know that I like to put my denominator factored out here. Okay, for me it's simpler to see how they cancel. Okay, so I'm going to multiply both sides times what? Times the least common denominator. Okay, on this side you have x minus 3 times x minus 2 And on the other side, you have that it's going to be x minus 3 times x minus 2. Okay? So please note that I need to multiply all of this chunk times this, so that one cancels the negative, the x minus 3. Okay, so you would have 2x times x minus 2 for this term. Now you need to multiply all of this times this one, which is pretty nice because it cancels entirely. Okay, so you have negative 4x minus 6. Okay, and this is going to be equal, and these two they cancel, so you have x times x minus 3. After that, we distribute each one of the terms depending on what we have. For example, here we have the 2x times x minus 2, so you have 2x squared minus 4x, and then here you need to distribute the negative here and here, so you have negative 4x plus 6, and then you have that this is equal to x squared minus 3x. Okay, at this point what you are going to do is you combine the like terms. This is your quadratic term, okay, so you know that it's going to be x squared. Okay, then we have the linear terms here, here, and here. That's going to be negative 5x, and then you only have your constant term, which is the plus 6, and that's going to be equal to 0. So at this point you are like, oh, okay, so we can factor the situation. And yeah, it's true indeed. Okay, so how can I factor it? You know that it's going to be x minus 2, x minus 3, and this is going to be equal to 0. Okay, so knowing your algebra pretty well, you know that your solutions are going to be x equals 2 and x equals 3. Okay, but then you are like, okay, so here I have an issue. What's the main issue? Well, your restrictions. Look at your restrictions. These are, both of them, they are the restrictions, so we are kind of sad because none of them are solutions. So what's your solution? The empty set. Okay, so the empty set is going to be your solution in this situation. For problem number 6, what you are going to do is kind of like the same thing. You read it and you're like, okay, I have a difference of squares there, so that one I can basically factor it out as x minus 1, x plus 1. Okay, meaning that your least common denominator in this situation is going to be x minus 1, x plus 1. Okay, so the restrictions of the situation are going to be the following. Okay, so you have that it's going to be x such that x is going to be different than the first one that you don't want is the 1, and different than negative 1. Okay, so after that, what you are going to do here is you are going to multiply your expression, okay, times your least common denominator. Okay, remember that I really like to have my expression with the factor out, with the factors here. Okay, so I'm going to multiply this side times x minus 1, x plus 1, and the other side times x minus 1, x plus 1. Okay, so with that being said, now you're going to multiply this times this, okay, canceling the x minus 1 here and here, so you have x times x plus 1. Okay, after that you are going to multiply all of this times this, so you have plus 2 times, and the x plus 1 cancels, so you only have the x minus 1 here. On the other side, you have all the least common denominator, therefore they cancel, so you have x squared plus 3x minus 2 alone, because this basically cancels with this. Okay, now let's distribute this situation. You know that it's going to be x squared plus x plus 2x minus 2, and this is going to be equal to x squared plus 3x minus 2. Once you are here, you are like, okay, I need to combine the like terms. You have your quadratic terms, which they cancel. Okay, this is a 3x that cancels with this 3x. Okay, so they cancel. So you have negative 2 is equal to negative 2, which you know that this is a true statement. Okay, and you're going to tell me, oh, again, it's all real numbers. Well, almost, right? but you have restrictions. That's the issue that we have in this situation. So honestly, what I would do, writing this in interval notation, it would be from negative infinity to positive infinity, but eliminating the 1 and the negative 1. So I would write negative infinity to negative 1 without including the negative 1, union negative 1, 1, union 1, infinity. This would be my interval notation. Okay, if you prefer the set notation, what would be the set notation here? It would be x such that x is different than 1 and x different than negative 1. So technically is the restriction that you have here. Okay, and that is it for solving rational equations.